Hey guys, welcome back to Include Electronics with another video, and in this video we are going to make upgraded surveillance camera car with pan tilt control. Using this pan tilt assembly we can rotate the camera horizontally and vertically from 0 to 180 degrees. We will capture images using ESP32 camera module and send these images to our mobile phone using WebSocket through Wi-Fi connection. We will control car using our own mobile app. So let's get started and make this car. If you haven't subscribed yet, please hit subscribe button below and press bell icon to get latest updates. We will need following components: ESP32Cam module, pan tilt servo assembly, SG90 servo motors. We will need 2 motors, 4WD car kit, this car kit comes with car chassis, 4 TT gear motors, wheels, connectors and screws. We will also need L298 motor driver module, UBC or buck converter to provide 5V to servos, 7 to 12V DC rechargeable battery, in our case LiPo 2S battery, Arduino Uno for uploading code, double-sided tape and few jumper wires. Let's first assemble the pan tilt bracket and fix servos. Please check my video on pan tilt control for detailed assembly. Let's assemble the car now. First, let's solder wires to gear motors. Mount all 4 motors on car chassis using connectors and screws. Now attach both the car chassis plate using screws and make sure that it is tightened properly so that we don't have any loose part. Join red to red and black to black wires of DC motors on each side. Attach L298 motor driver module on car chassis now. Now let's make a connection as per circuit diagram. Connect right side motors to out 1 and out 2 pins of L298 motor driver module. Now connect left side motors to out 3 and out 4 pins of motor driver module. Now connect L298 motor driver module to ESP32Cam pins as per table. Connect both Enable A and Enable B pins to IO02 pins of ESP32Cam. We will take plus 5V and ground from L298 motor driver module and provide to ESP32Cam module. Fix ESP32 camera module on bracket now. Mount pan tilt assembly on car chassis now. Connect pan servo and tilt servo to IO14 and IO15 respectively. Connect UBC to battery supply and provide plus 5V and ground to servos. Attach DC battery power connectors to motor driver module to plus 12V pin and ground pin. Attach wheels to car now. Let's take a quick look at the code. First, we need to install ESP32 board using Arduino Board Manager. I have provided the ESP32 board link in the description below. Go to File, then go to Preferences and add the ESP32 board link. Then go to Tools and then Board Manager and search for ESP32 and install it. After that, we need to install the Async TCP and Async Web Server library. Download these libraries from the links provided in the description below. Once downloaded, go to Sketch, Include Library and then click on Add Zip File. Select the downloaded zip library file and click Add. Similarly, add Async Web Server library as well. Now we need to set one parameter which is very important step so that video runs smoothly. Go inside your Sketch folder, then Libraries folder. Search for ESP Async Web Server folder and then go inside SRC folder. Open async websocket.h file and change WS max queued messages to 1 for our ESP32 board and save it. Now we need to install ESP32 servo library as well for controlling servo motors. Go to Tools and then Manage Library. Search for ESP32 servo and install it. Now we need to include the ESP_camera, Async TCP library and Async Web Server library. Also we need to include ESP32 servo library as well. After that, define pan and tilt servo pins as IO14 and IO15. We have created objects for pan and tilt servos. We no longer need to create any dummy servos because of timer issues. I have figured that issue and sorted out by changing timer used by camera settings. We have assigned the right and left motor pins. We will use single IO2 pin for enable A and enable B pins of motor driver module. Then we have defined light pin as IO4. We have defined some constant for car movements. We have set PWM frequency resolution and channels for speed and light. We have defined some settings related to camera. We need to set the SSID and password for our ESP32 Wi-Fi. We have created web server at port number 80. We will be using WebSocket for camera and servo input control. Then we have created HTML page for our car control app and stored it in HTML homepage variable. This is the main page which will be displayed on mobile. It has image section to display the video and also has all buttons to control the car. When any control button is pressed on mobile, it will send particular number to ESP32 using WebSocket. We have created WebSocket to display the image sent from the car. We have created rotate motor function which takes motor number and direction as arguments. It will rotate motor in forward or backward direction. Then we have move car function which will take command like up, down, left, right, stop and move the car accordingly. We have handle route function which will send the HTML page when we type IP address on mobile browser. We have on-car input WebSocket event callback function which will be called when ESP32 receives any command from mobile. If received control is move car, then we will call move car function. If received control is speed, then we will set the car speed. If received control is light, then we will set the flash. If received control is pan or tilt, then we will move the servos accordingly. We have on-camera WebSocket event callback function which will be called when we get request for video stream. Once connected, we will set the client ID. We have created setup camera function to init the camera. Then we have created send camera picture function which will capture the image and send it to camera WebSocket client. We have created setup pin mode function to set up the servos. It will attach servo pins to servo objects. It will also set the motor pins as output. Inside setup function, we will call setup pin mode function. Then begin Wi-Fi using soft AP mode. Setup callback function on root and on not found. Then attach the WebSocket handler to web server. Now begin the Wi-Fi server. Also set up the camera. Inside loop function, we just need to call cleanup client function to clean up old client connections. We will also capture and send the camera images. I have provided the link to the code in the description below. You can upload it directly. In our case, we will use Arduino Uno for uploading the code. Check my previous video on ESP32Cam car for detailed explanation on how to upload code using Arduino Uno. Connect battery to car now. Let's open mobile app now. Go to Wi-Fi settings and connect to my Wi-Fi car SSID using password as 12345678. Open Google Chrome browser on mobile and type 192.168.4.1. It will open our camera car control app. Sometimes we might have to reconnect the Wi-Fi if app does not open. That's it. Let's see how it works. We need to remember some important points. We need to set WS max queued messages to 1, otherwise the video will be very slow. If video is not displayed on the app, then reconnect the Wi-Fi on mobile. Do not connect IO16 pin of ESP32Cam. It is used internally by PSRAM. If uploading of code fails, then try after reconnecting USB cable to laptop. Make sure to provide separate 5V DC supply to servos. The power supply should have more than 2 ampere current. Hope you guys enjoyed the video and thanks for watching. Stay safe and please like, share, comment and don't forget to subscribe to my channel.